Climate change is happening now. Our oceans, coastlines, and coastal communities are being threatened. This raises the question of whether we can do anything about it. One possible answer to this is blue carbon. The ocean plays a central role in regulating the Earth's climate. Increases in atmospheric carbon dioxide are responsible for about 2/3 of the total energy imbalance that is causing Earth's temperature to rise. According to the United Nations, within the next 2 decades, global temperatures are likely to rise 1.5 degrees Celsius. According to NASA, the last 7 years have been the warmest on record. And according to the National Institute of Environmental Health Science, more than 1 million species are at risk of extinction by climate change. What is wrong with carbon? First of all, carbon dioxide is a greenhouse gas. This means that it causes an effect like the glass in the greenhouse, trapping heat and warming up inside. Human activities have increased the concentration of carbon dioxide in our atmosphere, amplifying the Earth's natural greenhouse effect. This video here is a time series between 2002 and 2016. It shows the global distribution and variation of the concentration of mid-tropospheric carbon dioxide in parts per million. The overall color of the map shifts toward red, with advancing time due to the increase of CO2. Atmospheric warming is leading to the melting of inland glaciers and ice, causing rising sea levels with significant impacts on shorelines, such as coastal erosion, saltwater intrusion, habitat destruction, and coastal human settlements. Blue carbon is the term for carbon captured by the world's ocean and coastal ecosystems. Blue carbon ecosystems like mangroves, salt marshes, and seagrasses play a vital role in carbon storage and sequestration. They hold 70% of the marine carbon and only cover half of the area. These ecosystems have incredible burial efficiency. They are able to fix 400 to 800 grams of carbon per meter squared per year and have a burial rate of 80 to 110 grams of carbon per meter squared per year. They have a 10% efficiency and are able to recycle 90% of carbon. Blue carbon ecosystems fix carbon at the same rate as terrestrial plants, but the burial efficiency is up to 40 times higher. For example, macrophytes are aquatic plants growing in or near water. They include mangroves, seagrasses, and salt marshes, which all form highly productive blue carbon habitats, storing in their sediments a large stock of organic carbon. They not only help mitigate climate change but also absorb incoming wave energy. They adapt to rising sea levels and enhance food security and local communities, providing more resilience and at often lower costs than great infrastructure. Blue carbon ecosystems sequester carbon faster and far more efficiently than in terrestrial forests. When these ecosystems are degraded, lost, or converted, massive amounts of CO2 are released. An estimated 0.15 to 1.02 billion tons every year are released into the atmosphere, or oceans, accounting for up to 19% of global carbon emissions from deforestation. Hence, these systems must be protected and managed well. Seagrasses are great carbon sinks. Fixed carbon is stored as a carbohydrate in rhizomes. Rhizomes are stems extending horizontally or vertically below the sediment's surface. They are not broken down due to low oxygen levels, thus carbon remains for thousands of years. Seagrass also filter river-derived particles from the water that contains carbon, which could be up to 50% of the captured carbon. Unlike terrestrial soils, the sediments in which healthy mangroves, salt marshes, and seagrass meadows grow do not become saturated with carbon because sediments accrete vertically in response to rising sea levels. For example, a 2011 study by Elizabeth McLeod showed that seagrass such as Posidonia oceanica meadows in Portligat Bay in Spain and mangroves such as Rhizopora mangor systems in Belize have accreted carbon-rich deposits that are more than 10 meters thick and are over 6,000 years old. The longevity of blue carbon sinks is impressive when compared with rainforests, which are reported to sequester carbons for decades or centuries at most. Blue carbon ecosystems within oceans are a powerful tool in reducing the amount of carbon dioxide in the atmosphere. They must be protected, and if damaged, an enormous amount of carbon will be emitted back into the atmosphere and can further detrimentally contribute to climate change. The sustainable management, conservation, and restoration of coastal and marine ecosystems are vital to support the continued provision of carbon sequestration and other ecosystem services on which people depend on. Today, most countries can get involved to create climate-smart marine protected areas. Protecting, managing, conserving, and restoring are all methods that support the Sustainable Development Goals, such as climate action, which is number 13, and 14, conserve and sustainably use the oceans, seas, and marine resources for sustainable development. The call for collaborative help internationally will help to achieve a better and most sustainable future for all. Countries must act now to implement and strengthen commitments to include blue carbon ecosystems in NDCs, National Determined Contributions, and climate action plans to commit to increased transparency for carbon accounting and implementation methods committed to incentivizing conservation, protection, restoration, and reducing exploitation to increase sustainability management. Marine protected areas, for example, can protect ecologically and biologically significant marine habitats, including regulating human activities to prevent environmental degradation. Countries can also develop policies and ensure the implementation of sustainable practices in all industries that impact the oceans and coasts. The support for scientific research is also needed. This will ensure the continued monitoring and analysis of the impacts of climate change, with the knowledge gained used to design and implement adequate and appropriate mitigation and adaptation strategies. And in order to follow the Paris Agreement and avoid dangerous climate change impacts, it is crucial to understand the mechanisms of blue carbon ecosystems as they are able to adapt to climate change. There are many questions regarding blue carbon ecosystems that are yet to be answered, such as how does climate change impact carbon accumulation in mature blue carbon ecosystems? How does disturbance affect the burial fate of blue carbon? And what management actions best promote blue carbon sequestration? Therefore, research and developments are still required to discover more about this critical area of emerging science.